Hey everyone, I hope you are doing well. And for today, I would like to offer you a journey to space, to the red planet. So, what I need you to do now is just relax and maybe close your eyes and let the sound of my voice guide you through this journey, during which we will discover plenty of things about the history of the observation of Mars, how it moves and revolves in the solar system, and what would be the conditions we would find if we walked on its surface. Mars has been known by man since the dawn of antiquity, because this planet is the closest one to the Earth in the solar system, and it can easily be seen without any elaborate mean of observation, so that like Venus and Jupiter, it was quickly identified and often given a particular symbolism or meaning in early civilizations. As the means of observations developed, especially from the 16th century onwards, scholars started to examine its surface with telescopes and started to wonder if Mars could be inhabited. And in the 19th century, this is not this old, various scientists observed that there were apparently like canals on the surface of Mars, and this validated the idea that life and maybe an elaborate civilization occupied the surface of this planet, so that until the planet was explored by space probes from the 1960s, the idea that life existed on Mars was relatively common, and this made the imagination of scientists and writers sparkle, giving birth to various stories, various tales and legends about the Martians, how we could meet them, how they could maybe come to Earth and invade it. But these speculations vanished when space probes and more recently a rover explored the surface of Mars. Maybe life existed on this planet one day. There is water, but today there is apparently no elaborate forms of life on Mars. But nevertheless, the planet remains particularly interesting, and if one day another planet in the solar system is populated by men, it is probably going to be Mars. But let's see what we have there, and for that we need to leave the Earth on our way to the red planet. The big problem when it comes to leaving our planet is that the gravity makes it difficult to go to space. Our mass, the quantity of matter we are made of, is attracted to the Earth by the gravity, which gives our mass a weight, and lifting this weight high enough to get out of this field of attraction of the Earth is something that requires quite a lot of energy. And this is why the rockets, the spaceships, need powerful engines that make it possible to compensate for this gravitational force and escape the Earth. Once we would leave the Earth and come to space, we would become much freer to move, and we would feel like our bodies have no weight. They still have the same quantity of matter, but this mass is not turned into weight by gravity. And once on the surface of Mars, we would be exposed to very different gravitational conditions than on the Earth, because Mars is a smaller planet. It is about 11 times smaller than the Earth in terms of volume, and for that reason the gravity on the surface of Mars is only about 1/3 of the gravity we know on the Earth, so that our weight would be 1/3 of the weight we have on our planet. But before we reach Mars, there is a relatively long trip to make. The distance between the Earth and Mars is changing all the time, because the two planets are revolving around the Sun, and they have different orbits. These orbits are not round, they are elliptical, and depending on the moment, sometimes the Earth can be on one side of the Sun and Mars on the other side, or there can be a moment when the planets are aligned in front of the Sun, and the two planets are revolving at different speeds too. It takes about twice more time for Mars to make a revolution, an entire circle around the Sun, and as you know, for the Earth it takes 1 year to make a full revolution. For Mars it takes almost 700 days. So that the moment when the two planets are the closest is when they are in what is called opposition, when they both are on the same side of the Sun and perfectly aligned with it. When this is the case, the distance between the Earth and Mars corresponds to 3 minutes at light speed. But when the Sun is in between the Earth and Mars, this distance becomes 22 minutes at light speed, 7 times more. So that if a spaceship is to travel from the Earth to Mars, it would be important to take into account the orbits, the timing, and the speed of this ship to calculate the trajectory and optimize it. And given that we don't know how to travel in space at the speed of light, given that the ship would have to accelerate and decelerate, it would take 6 to 9 months to do the trip. The good thing with the mind is that it travels at the speed of light or even more, so we can say that we are already there. And when we would arrive at the periphery of Mars, we would see the planet with this specific red color, which is coming from the quantity of iron and its oxidation. Mars has the color of rust for that reason. As we would come closer to the ground of Mars, we would realize that there is an atmosphere on this planet, like on the Earth, but a very different one. And this explains that the conditions at the surface are very different from what we are used to. The atmosphere on Mars has a much lower density than on the Earth. It has about 1% of the density of the terrestrial atmosphere, and this explains that the temperature at the surface of Mars is very different from the one on the Earth. The temperature on our planet is regulated by the atmosphere, and especially through the greenhouse effect. The greenhouse effect is a mechanism due to the atmosphere that prevents the heat from escaping in space and maintains temperatures that are relatively stable on the surface of our planet and much hotter than the temperature of space. On Mars, the atmosphere is very thin. There is very little greenhouse effect, and the temperature is much colder than on the Earth. It drops to, in average, minus 63 degrees Celsius, and it can be even much lower in some parts of the planet that are less exposed to the sun. But there are days and nights on Mars because the planet is rotating on an axis, and like the Earth, which is making a rotation in 24 hours, Mars is rotating almost at the same speed, making that the days last a bit more than 24 hours. So the temperature on the surface is also changing regularly depending on the angle with which the surface is exposed to the energy coming from the sun. Because the atmosphere is less dense than on the Earth, we would be immediately submitted to a drop in pressure. I talked about the importance of pressure in the video about the deep sea, and here on Mars, like in space almost, the absence of pressure around our bodies would make them inflate dramatically and could kill us almost instantly. So before Mars would be inhabitable one day, we would need to create an atmosphere for the planet that would be dense enough to make it possible for our systems that have evolved based on the conditions on the Earth to survive. And it would also be necessary to inject oxygen in this atmosphere so that we would be able to breathe like we do on our planet. This is not going to happen anytime soon, but maybe in a distant future it would be possible to imagine a terraformation of Mars, because there is water on this planet, and water means that the conditions are theoretically possible to create. In water you have a large quantity of oxygen, and you have a place where forms of life, microbian lives, basic plants can survive and maybe contribute to create this atmospheric oxygen we would need to breathe normally. However, today there cannot be any liquid water on Mars, not only because of the temperature that is so low that it turns water into ice, but because of the pressure. The pressure is very limited, very low, so that liquid water immediately turns into gas on the surface of Mars and vanishes into space. Another consequence of the absence of a dense atmosphere is that meteorites can easily reach the surface of the planet. On the Earth, our atmosphere also protects us somewhat from objects coming from space that are burnt in the highest parts of the atmosphere, giving birth to the famous shooting stars we can sometimes observe at night, whereas with this very limited atmosphere, the surface of Mars is not protected from asteroids and meteorites, and its surface contains many holes, many craters made by the impact of these meteorites. And the surface of Mars, like on the Earth, is also shaped by a volcanic activity which is comparatively less intense than on the Earth, but that has given birth to some of the biggest volcanoes known in the solar system. And the biggest of these volcanoes is called the Olympus Mons, standing for the Mount of Olympus in Latin, which is 21 kilometers high. This is more than twice the size of the Everest on the Earth, and a large shield volcano, like the volcanoes that gave birth to the Hawaiian Islands, with an escarpment and a large aureole around. Comparatively, if this volcano was on the surface of the Earth, it would cover the surface of Texas or a country like Germany. So you see how large these volcanoes can be. Okay, we are now making a last revolution around the planet, and we are going to return to our home, the Earth, maybe dreaming that one day man will be able to turn Mars into a second home for humanity. I hope you enjoyed this moment spent together, and that I will see you soon for another presentation. Bye bye, my friends.